Thank you, Dr. Roopesh, for being a part of this conference. It was a wonderful presentation, but we would like to know more about your research.
Okay.
So, tissue engineering is a interdisciplinary subject, like it's a combination of biology and engineering. So, how do you think this combination is helping this liver failure treatment or the research?
Yeah, so basically, if you look at the field of liver tissue engineering, recently there has been more and more technologies which have combined the principles of engineering and the biology for the making of liver tissue models. So, and this particular combination is very effective because from the biology side, you can have the cells self-assemble and form organoids-like models, which are very relevant for the liver tissue engineering purpose. But the problem is that all these self-assembled or the cell-defined models, they have a limitation or restriction in their size. So when we talk about regenerative liver regeneration or liver transplantation, which is our long-term goal, we need to have a tissue construct which is in the scale of centimeter or a meter. So when you want to build a macro scale tissue construct, just using the cells or the cell structures like organoids alone cannot be sufficient. So what we do, we include some automated engineering technologies like the bioprinting. So when we combine this bioprinting, which is a method to fabricate macro scale tissue constructs with these organoids or other cellular structures, we can, it will enable us to build larger tissue constructs. At the same time, the tissue architecture and other cell functions can be maintained within this tissue construct. So this actually tells you that both the combination of this engineering and the biological principles are very essential for tissue engineering, and particularly liver tissue engineering.
So, from your research experience so far, how do you feel? Is this combination successful?
Yes, it is really successful, but there is a lot to do because
we have a lot.
We have a lot to go ahead because we have some limitations or challenges in this goal, like in the way of achieving this goal, because the organoids, from the organoid side, they have some limitations, like most of the organoids, they are developed from stem cells. So the kind of maturity that we get in the final differentiated organoids is comparatively less compared to the real liver tissue or any other tissue of matter. So that is one factor that we have to overcome. So we have to get a completely mature tissue or liver organoids. So that is from the biology part. Looking at the engineering part, so the bioprinting is basically an automated form or like another form of 3D printing technology. So most of these bioprinting technologies are not that much compatible with the printing technology or the organoid bioprinting. So most of these bioprinting technologies has been developed for normal cell printing. So we have to make some developments or modification or improvisation in the bioprinting technology or the bioprinter device as such, so as to accommodate these organoids into this bioprinting strategy. So that is something which we have to do, or which is a future perspective.
Okay. So you are also part of GYRA. So and you are working on a very cutting edge technology. So how do you think we can equip our teacher coaches? Actually, they are not usually exposed to such techniques.
Yes.
How do you think we can equip them to train our scholars in these technologies?
Yeah, so the very first thing what we have to do is that we have to develop a scientific temper in them. So to develop a scientific temper in these students, the very first thing is we have to make them aware of the need for these technologies. Because most of the time when new technologies develop, they just show their capacity or their performance. But we have to make sure that before showing up these new technologies to the students or the children, we have to make them aware of the fact that why this technology is needed or what is the application of this technology. So then they get to know why they are using this technology or what is the purpose of using this technology. So in the last 1 year, have been collaborating with the students in Singapore. So we have around 5 to 6 students, and I hope I have tried my best to elicit the scientific temper in the students. So we also discuss some of these factors, like how to develop a research question at the first hand, and then we make hypothesis to deal with these questions, and then also the research methodology. So this is how we are currently dealing with in the GYRA Singapore team.
And the last question, what would be your message to young researchers who wants to pursue research? Especially GYRA scholars, we have been dealing with them for around 1 year.
Yeah.
So what would be your message to them?
So my message to the students is that always dream big and don't lose hope in between. So there are circumstances in the research which is inevitable, where you fail multiple times. So people try to give it up. They change their field, they go to some other fields. So try to be focused and always keep the will have a great will or a constant will to continue in the field even when there are failures. So that helps you to refine your hypothesis, because most of the time when you make a new hypothesis, to test the hypothesis, you have to make some methodology, and if you fail at the first time, don't give up. Try to modify or refine your hypothesis and come up with some alternative approaches to deal or test that hypothesis. So this will increase the creativity in the person. So always try to be focused and always dream big. That's my message.
Thank you, Dr. Roopesh.
Thank you.
Thank you for your time.